Okay, so last day of notes here. Okay, so we're dealing with confidence intervals for means. So this is confidence intervals for means. So x plus or minus t times s over the square root of n. Confidence intervals, we're dealing with confidence intervals for means today. X bar is a mean. And what we're dealing with is in the check for normality, which is condition 3, is checking the conditions. Condition 3, which is called the large sample size condition. Okay, so condition 3 is the large sample size condition. So when you're dealing with means, what type of sample size is a large sample size? Okay, 30. So n greater than 30 is considered a large sample size. All right, so what if n is not greater than 30? Nope, there's something else. N is greater than 30 or normal. Or the data is from a normal population. Okay? So many times you will just assume that. And there will be a test question where you have to do this that I'm about to go over. You have to do it on the test. Okay? And the homework today helps you practice that. So, okay, so when are we going to have to do something different than just assuming it's normal if n is not greater than 30? So when we checking for normality, that's when you're talking about normal population or not. When the sample size is small and the data from the sample are provided, so sample size is small and the data are and they give you the data, you must graph the sample to see if it could plausibly come from a normally distributed population. Okay, and there'll be an example. The next thing we'll do is an example. The best way to check for normality is with a normal probability plot. And we've had those before. We had to check for normality earlier in the year. In this type of plot, the closer the points are, this is telling you how to interpret that. In this type of plot, the closer the points are to a line, the closer the data is to normal. So you do your normal probability plot, and if it looks like a line, then you can say, yep, it's probably normal. Yeah, I have it right there. All right, so to make a normal probability plot, enter the data into a list and choose the 6th graph option in the stat plot menu. So here's just some samples. These are just graphs, normal probability plot. We'll do it on our calculator in the example. So don't worry about finding it right now. In the example, we'll do it on our calculator. So these are just some normal probability plots, okay? These are normal probability plots. Just examples of them. And what you have to do in condition 3, if you're dealing with a confidence interval for a mean, and n is not greater than 30, then you will have to sketch this graph on condition 3. You'll have to make it on your calculator, and you'll just have to do a rough sketch of the graph, just like they are here. Notice there's no numbers here. All it is an XY axis with some dots. And then you're going to need to make a statement. Okay, and down here we'll talk about the statements that you have to make to check for normality in condition 3. Now, what I found on AP questions is that the key parts of getting points are checking the conditions and interpreting things, not the calculation. So the calculation is minor, a very small part, like half a point maybe out of 4. So you have to be able to do all of this. All right, so normal probability plot. Do you think that's kind of linear? Yeah, okay, so I would say this is linear. Yeah, I would say that's probably good. So what does that mean about that graph? Is that approximately normal or not? Yeah. So we can assume that this is from an approximately normal population. Okay, and that would be sufficient. Since it's linear, so we draw the graph on our paper. We say it's approximately linear, and since it's linear, we can assume that this is from an approximately normal population. Okay, how about this one? Linear? How does that look very linear? No, that looks curvy to me. Okay, so this is not linear. Okay, not linear. Clearly curved. Okay, clearly curved. You can say not linear or clearly curved, whatever you want to say. So we cannot say that it is from a normal population. So what would I do in that case if I were writing a confidence interval? Would I stop? No, you never stop. You never don't do the confidence interval. What do? I will proceed with caution. Okay, so how about this last one? No. So I would say exactly the same thing as I did there, not linear again. I would proceed with caution. So basically all the bottom says it's kind of a recap of what we just wrote down here. These samples all came from normal populations. They actually did. Even though none of them look exactly normal. This makes the normality condition really hard to assess. So, however, this is how we'll handle it when using small samples. Again, this is for small samples, n less than 30. Okay, slight to moderate skewness is okay. So that is slight to moderate deviations from a linear pattern in the normal probability plot, that's fine. So then it kind of gives you a little script here. Here's what you could say. Since the normal probability plot is roughly linear, it's reasonable to assume that the population is approximately normal. That's kind of what we set up here, right? Kind of. And then if there is strong skewness or outliers, it makes this question questionable. So that is a big curve or an outlier. So since there is an outlier or since it's curved, it's questionable to assume that the population is normal. I will proceed with caution. So these are just suggested scripts. I mean, we wrote pretty much the same things up above. So that's what you're going to do for the third condition, large sample size, if n is not greater than 30 and they give you the data. So we use this for sample mean, x bar, third condition, and sample size is less than 30 and the data is given. The data is given. And I'll show you what I mean by the data is given on page 138 in our notes. So we're going to use this when we're dealing with the sample mean in the third condition when our sample size is less than 30. And the data is given. You have to make a normal probability plot. So here's what I mean. This is what your test question is going to look like. It's not the same topic, but it's going to give you something like this, and then it's going to give you data. This is the data that I'm referring to. The data is given. What is n here? What is the sample size? How many numbers are there? 8. So n is 8. So this is a very small sample size, so when we're checking conditions, the third condition is going to fail. Okay, we would have to just assume it's from a normal population. If you just assume that it's from a normal population in a problem like this, you will not get any credit for the conditions. Okay, you have to check the normal probability plot. Assuming it's normal isn't a way out. It's not a way of checking the third condition when you have to do it different ways. So here's our data. It's a small sample size. So when we write this confidence interval, we're going to have to do what we talked about over here.